Hi and welcome. Another question in preparation for maths methods. So is sort of assumed knowledge, background knowledge. And this one talks about a sphere that has a radius of 8 centimeters, which is inscribed within a right circular cone of radius r centimeters and height h centimeters. So we do have to show that the volume of the cone, so the volume of the cone V is given by this formula. So we also have hint here and it says look for similar triangle. Now, if you look at the volume formula for the cone, so you can actually see that we do have h as a variable, but there is no r, there is no radius, which it's sort of hint that we have to find radius in terms of h and then sub into the original equation for the volume of the cone and a little bit of algebra to actually show what has been required from us. So now we do know, so the first thing I'm going to do somewhere on the side, okay, the volume of the cone is 1/3 pi r squared times height. Okay, so cone. So this is the volume. Now let's have a look what is given. Let's change some colors. A sphere of radius, I'm going to use pen actually, a sphere of radius 8. So we have to be careful. Sphere, so this is the radius. So this is 8 as well as this. So this is 8, this is 8. And cone has a radius. I'm going to use different color. So cone has a radius, cone here, radius of r, and height of the cone is h. Okay, so we do have few variables that are given. Let's see how we can use it, to show the volume of the cone. So the next step, what I'm gonna do, because I already have this hint saying look for similar triangle. Okay, so that's what I'm gonna try to do, and by taking some triangles out of this picture, looking for the color. Okay, let's go with this green. So when I have this one here, this line there, and horizontal one, right angle. So pretty much what I have here, this triangle, is this triangle, okay, right angle triangle. Okay, so that's pretty much, that's the one. So I'm gonna do a little bit of labeling here. What is given, so radius of the cone is given and height is given. So here's the height. Okay, now let's have a look. Do we have another triangle? So, and we can see here, this one here, right angle triangle. It's even labeled for us. So that's another one. So I'm gonna draw it within this one. Maybe yellow. So that's, I'm gonna try like rip. This is sort of, right angle triangle. It's not to scale, but now labeling, I'm gonna put this is 8, and this one here is 8 as well. Okay, so now looking for similar triangles, I can take this triangle out here. Okay, out here. Maybe that would help to find corresponding sides. So let's take it out. I'm gonna use yellow, and it's gonna be like this. Okay, and we have that right angle, it's there. So we have 8, the opposite right angle triangle. In this case, it's hypotenuse, but I want to find, to label this length actually. So I want to label this length. So if all this height is h, this is 8, then this part here is h, take away 8. Yes, well done. So, and that is across, isn't it? Okay, across here. So that is h, take away 8. Okay. Do we have anything else? Not really. Let's have a look now at some corresponding side. If it does help, so you can, delete some of this if you want to, if it's confusing. Even maybe this number there. So you don't have to, but yeah. Okay. Maybe I'm going to undo now. Okay, it doesn't let me. It's okay. So I'm going to draw it again. Yeah. So now let's have a look at corresponding triangles. So we would have here R and 8 corresponding, okay? R and 8, okay? So I'm going to start writing, but maybe in different color. So blue, okay? Ratio between R and 8 should be equal to corresponding sides. In this case is h over, we have like, and we don't have this one, and I'm looking for this height, say, okay, which we don't have. But lucky for us, we do know Pythagoras. Let's label this x. Now, how do we find the unknown side in right angle triangle? X to the power of 2 equal hypotenuse, take away the other side. So hypotenuse to the power of 2, take away the other side to the power of 2. A little bit of calculation or expansion, h to the power of 2, take away 2 times h times 8, it's 16h, plus 8 to the power of 2 is 64, take away 64. This is beautiful cancellation, that is gone. And then we are back x to the power of 2 equal to h to the power of 2, take away 16h. I think I can talk a little bit faster than this. Trying to be funny. The next step is to have x by itself. So we're gonna do square roots both sides. So this is gonna be x square root of x to the power of 2, take away 16h. So we now have x by itself. So you do know when we are taking square roots on both sides that we do have solution plus minus, but in this case, because we're talking about the length, so it is not going to be negative, it's just going to be positive. That's why I don't have negative solution included. Now what we're going to do, we're going to take this x and put in denominator, because that is corresponding side to h. So that's going to be this. Okay, and let's do a little bit of algebra. Now, again, it depends what do you prefer, how you're going to do it. As I said before, usually I go with cross multiplication, but, I'm not explaining here why actually this method works. So that's, in previous years, so cross multiplication, it means you multiply, in this case, r by h to the power of 2, take away 16h, and then it's equal to 8 times h. As I said before, we need r by itself. So the next step is to divide both sides by square root of h to the power of 2 take away 16h. And now we do have r by itself. We still don't have this volume of the coin in this form. So that's what we're going to do next. I'm going to use, which one, what color is going to stand out? Yellow. So volume in terms of h. So we do know it's 1/3 pi, as we said before, 1/3 pi. Now r, we're going to use this r. So we need r here. So we're going to use this one there. Let's go back to the column. And now replacing r is 8h over square root of h to the power of 2 take away 16h. Don't forget everything to the power of 2 and then times h. Again, a little bit of algebra. Lucky we love algebra. So, and then, because when you have brackets into the power of 2, it means that everything inside, oopsies, is to the power of 2. I think I'm trying to delete everything. So 8h is to the power of 2, and whatever in denominator is to the power of 2. And, okay, I wasn't thinking of having that step, but, okay, I'm going to include it. So h to the power of 2 take away 16 to the power of 2. But now we can cancel out 2 and square root. So, and what color? Yellow. One more step. Most likely 2 more steps, but yeah. Just tidy up a little bit. So x to the power of 2 times, h to the power of 2 times h is h to the power of 3. So h to the power of 2 take away 16. So we still don't have what we need. So, but what we're going to do, 1/3 pi 64h to the power of 3. And then what we can do in denominator, actually factorize, taking h outside the brackets. So it's h. Wow, I left one h before, so I have to go back to the. I'm gonna show you where do I go, like from here to there. My substitution of r. No, from here to there. So that's gonna be in red. I'm glad you asked. Okay. Thank you. Okay, now it is gonna work out. What is beautiful? We can cancel out one h. You're gonna be left with h to the power of 2, and therefore we should now have the final answer, or the answer that has been requested, and h take away 16. So this is the answer. In case you're wondering the way that it has been written differently, so it's just pi's in the numerator 64, h to the power of 2, 3 times h take away 16. So it's the same thing. I still have pi in the first spot instead of second according to what is requested. So when you have to show something in a question, please make sure actually is written the same way as asked. Okay, I'm hoping this is helping, and I see you in another video. Bye.